Hey everyone, and welcome to this architecture breakdown explainer. If you've ever worked with Kubernetes, you definitely know that honeymoon phase, right? You start out with a few pods, maybe a dozen namespaces, and everything just feels so sleek and manageable. But then, well, reality hits. You scale. And suddenly, you're looking at hundreds of microservices scattered across multiple clusters, and man, the pain of scaling infrastructure becomes very, very real. So today, we're going to look at exactly why this happens and how the industry's most advanced organizations are actually solving it. Let's get into it.
Okay, so here's our agenda for today. Basically our blueprint. We'll start with the challenges of scale, look at the birth of platform engineering, break down the core 5-layer platform architecture, dive into GitOps as the single source of truth, cover monitoring, security, and multi-cluster setups, and finally, how to make Kubernetes disappear.
All right, section 1, the challenges of scaling.
So we kind of have to acknowledge a fundamental truth here. Actually installing Kubernetes, that's the easy part. But managing 100 developers, 30 project teams, and 5 distinct clusters? Yeah, that is a completely different beast. I mean, what happens when a company grows to 500 microservices across multiple clusters without any centralized management? Well, you get total operational chaos. Developers are constantly asking, wait, how do I deploy this? Security is panicking, demanding to know who has access to a specific secret. Operations is running around tracking down rogue network policies. And finance? They're screaming about cloud costs. Nobody is asking how to use a specific command anymore. They're all just asking how to manage this monster they've created.
And this right here perfectly illustrates that breaking point. You see, the early DevOps ideal was this beautiful dream, right? You build it, you run it. The whole idea was that developers would deploy, monitor, and manage their own code. But at enterprise scale, that completely collapses. Every single team ends up managing Kubernetes their own way. So you end up with 30 different deployment methods, 20 distinct monitoring setups, a tangled web of 15 CI/CD pipelines, and absolutely zero governance. There's literally no standard and zero consistency. It's a mess.
Which brings us to section 2. The birth of platform engineering.
So that exact operational nightmare we just talked about, that's exactly why large enterprises are being forced to completely shift their strategy. And the crucial point here is a massive paradigm shift. They are establishing a dedicated platform team. But, and this is a big but, this team's job is not to deploy applications for developers. Nope, their job is to build a product, a self-service platform providing Kubernetes as a service internally. Basically, they act exactly like a public cloud provider, but entirely within your own organization. It empowers developers to just self-serve without needing to be infrastructure experts themselves.
Moving on to section 3, core 5-layer platform architecture.
To really get how this internal cloud provider model works, let's break down its structural blueprint. Think of it kind of like building a skyscraper, working from the foundation all the way up. So, layer 1 is your infrastructure. That's the raw compute, storage, and network, whether that's VMware, bare metal, or public cloud. Right above that sits layer 2, the Kubernetes layer, which houses your control planes and worker nodes. Then comes layer 3, the platform layer. Think of this as the engine room, containing GitOps, monitoring, logging, and your service mesh. Next up is layer 4, the developer portal, or IDP. This is like the shiny, welcoming lobby of our skyscraper. And finally, at the very top is layer 5, the application itself. The real brilliance of this architecture is that your development teams only ever interact with layers 4 and 5. That whole complex foundation underneath, it's completely abstracted away.
Section 4, GitOps, the single source of truth. Now, this is the core engine powering that middle platform layer. If you look at the traditional way engineers interact with clusters, direct bash scripts or just running a quick kubectl apply, it seems really fast, sure, but it is incredibly dangerous at scale. Like, who deployed it? When did it change? How do we roll it back? You just don't know. Changes are totally untrackable. Well, GitOps fundamentally changes this. Instead of direct access, every single change goes into a Git repository as plain text. A developer makes a pull request, it gets automatically reviewed and merged, and then tools like Argo CD or Flux CD automatically sync that exact state to Kubernetes. Git becomes the sole unchangeable source of truth. It's a total game changer.
All right, section 5, monitoring, security, multi-cluster.
To actually build out the rest of a robust platform, you absolutely need these operational pillars. For observability, you need metrics tracking things like CPU and memory, and that's typically handled by the industry-standard combo of Prometheus and Grafana, alongside some really robust logging through Loki or Elasticsearch. Then, of course, there's security. Enterprises rely on tools like Trivy for image vulnerability scanning and Kyverno for admission control. That means any pod that doesn't meet strict compliance rules, it's instantly rejected before it's even deployed. No way gets through.
And finally, when you graduate from just one cluster to dozens across staging, production, and edge environments, multi-cluster management platforms like Rancher or Karmata become absolutely essential. They give your administrators a single pane of glass over the entire empire.
Section 6. Make Kubernetes disappear.
Okay, we've talked about a lot of complex tooling, but the ultimate purpose behind all this machinery is actually incredibly counterintuitive. It creates this amazing Wizard of Oz effect. Just look at this automated flow. A developer simply logs into the developer portal and clicks a button to create a service. That's literally it. From there, the platform automatically generates the plain text, pushes it to the Git repository, triggers the CI/CD pipeline, and then Argo CD syncs it straight down to the Kubernetes platform. It's magic.
And while that automated top-down flow is happening, this massive foundational machinery, the monitoring, the logging, the rigid security protocols, and the infrastructure provisioning is silently doing its job right in the background. The platform is automatically spinning up namespaces, configuring ingresses, and assigning storage classes. The developer doesn't need to know what a CNI is. They don't need to understand complex network policies. It all remains entirely hidden behind the curtain.
Which brings us to this incredibly punchy defining philosophy. The goal isn't to make everyone learn Kubernetes, it's to make Kubernetes disappear. This is the ultimate aha moment of platform engineering, folks. The next evolution of container orchestration isn't about teaching your developers more commands. It's about designing an internal developer platform that's so seamless and so well architected that the underlying complexity vanishes completely from their daily workflow.
Because ultimately, the future belongs to those who build platforms, not just those who deploy pods. True enterprise scale requires systems thinkers, people who can weave Linux, containers, security, and observability into one cohesive product. So the real question is, as infrastructure continues to evolve, are you going to keep manually fighting fires every day, or are you ready to build the platform? Thank you so much for joining me on this explainer. I really hope this breakdown gives you a powerful new perspective on your own architecture.